We're looking at these are FRQ area problems. So let's look at number 1 here. Let R and S be the region in the first quadrant shown in the figure. So we have region S here, and then we have region area, region R. Region R is bounded by the x-axis. So here's the x-axis. The graph 2 minus x cubed. That's the vertical portion here, or the right graph here. And y equals tangent of x. That's the left graph. The region S is bounded by the y-axis, so y-axis, 2 minus x cubed, and y equals tangent of x. So part A says find the area of R. So we want to find the area of this region R. And to kind of focus on region R, I drew another example right here. So if we look at region R, one way you can find area is we can do top minus bottom, so the top curve minus bottom curve. But the problem is if we can't just rely on just one equation to do that, because notice that the top curve of R is going to change graphs at this point here. So we need to, if we want to do top curve minus bottom curve, we have to treat R like two separate regions. And we can do top minus bottom for this region. So this will be the tangent x minus 0 from 0 to 0.902. 0.902 is the x value of the intersection between the two curves. And then that will be the area of this first region, left region. And then the right region will be top minus bottom with a different top curve. And this top curve will be 2 minus x cubed. So it'll be 2 minus x cubed minus 0 between 0.902 and this x-intercept, which is, if we set the y equals 2 minus x cubed equal to 0, we're going to get x equals cube root of 2. So that is one way that we can find region R. So we do top minus bottom from 0 to 0.902, tangent of x minus 0, and then the minus 0 just kind of washes out since 0 is not going to affect anything. And here, top minus bottom is 2 minus x cubed, that's this curve here, 2 minus x cubed minus 0, and that will take care of the area of the right region. And again, the minus 0 drops out from 0.902 to cube root of 2. So that's the top minus bottom method. Another way that we can find region R is we can do right minus left. Now, if we draw horizontal lines to, no matter where you draw the horizontal line, the right endpoint of every horizontal line that you draw is going to hit the same curve, same right curve. And then the left curve is always going to be this tangent of x graph. So we could just rely on using one equation, right minus left, if we want to do, if we want to just resort to one equation. But if we do right minus left, we have to make some adjustments. The equations have to be as it has to be in terms of y, so it has to be x equals an equation. So we can also work it out that way. So kind of walk through that as well. So this curve, this right curve, is y minus 2 minus x cubed, but we want to write it as x equals. So if we solve for x, it'll be 2 minus y cube root of 2 minus y. So 2 minus y to the 1/3 will represent this curve here. And then this curve, it was initially y equals tangent x, and if we want to rewrite it as a function of y, then we have to solve for x. So to solve for x, we take the inverse of both sides, so x equals arc tangent of y. So then arc tangent of y is the equation of this curve. So then also the bounds have to be changed because our bounds have to be in terms of y. So the lowest y value of this region, instead of going from left to right, we're going to go from bottom to top. So the lowest y value is 0, that's the x-axis, and the highest y value is this point right there, and that y value at that point is 1.266. So that's an equation that we can do. Right minus left will be the integral from 0 to 1.266. Right curve minus left. Right curve is this 2 minus y to the 1/3 minus, then the left curve is our tangent of y. All right, so if we find the area using either methods, we'll be able to get to the area of R. Okay, part B, if we want to find region S is this region here. We can do top minus bottom. If we do top minus bottom, it'll be this curve, which is the 2 minus x cubed minus the bottom curve, which is the tangent of x. Notice that this top curve is consistently the same from the left endpoint to the right endpoint of the region S, and the bottom curve is also consistently the same from left to right. So there's no need to split up our area S equation. We can just do top minus bottom, so 2 minus x cubed minus tangent of x, and then we're finding our balance has to be in terms of x values. So the furthest left, the furthest x value of the region S is 0, and the furthest right is 0.902. Okay, so that's one way to do it. Another way that we can do this is if we want to split this up and do it in terms of right minus left, we could also do that, but probably most likely will not be your first choice. But just to practice, we can do right minus left, but if we think of this as the right curve and this is the left curve is staying consistent no matter where you draw a horizontal line. But depending on where you draw a horizontal line, there's going to be a change in the right curve at 1.266, right? Below 1.266 is going to be the arc tangent, and then above it will be 2 minus x cubed. But if we do right minus left, we have to adjust our equation. So this equation will now be converted to 2 minus y to the 1/3, and then this bottom equation is now our arc tangent of y. So if we do right minus left, the top portion will be 2 minus y to the 1/3 minus 0 from 1.266 to whatever this y value is, which is 2. Okay, and then the bottom portion will be right minus left. The right is the arc tangent, and the left is 0, so arc tangent minus 0 from 0 to 1.266. And then we just plug in our calculator and then find the area. And the area for both of these should be the same. The area for both these methods should be the same as well. All right, number 2. Let R be the region bounded by the graph y equals e to the 2x minus x squared and the horizontal line y equals 2. So region R is just this little portion above this horizontal line and the curve. S is the region bounded by the graph y is equal to 2 minus x e to the 2x minus x squared. The horizontal line y equals 1 and y equals 2. So it's going to be this middle portion here. Okay. Bounded by the curve and the two horizontal lines above and below. Find the area of R. So if we want to find the area of R, we can just do top minus bottom between our left and right bounds. So our left bound, if we set the curve equal to y equals 2 and look for those intersections, those x values will be 0.446 and 1.554. So we can find the definite integral from our left bound to our right region, right bound, 0.446 to 1.554, and then top minus bottom. The top curve is e to the 2x minus x squared, and the bottom curve is y equals 2. So we have an area equation there, and then we plug that in our calculator to find the area of R. Okay. Another way, and then for part B, if I want to find region S, there's two ways that we can do this. We can split this up into 3 separate regions and then do top minus bottom for each of the regions. Or we could find the area of this entire region from 1 to whatever this x value is, okay, and then just subtract out region R, right? So if we go from 0 to this point, to 2, I think, yeah, this is at 2. From 0 to 2, we can, then it'll give us the entire area here, and then we can just subtract out the R. So it's basically region R plus S minus R will give us region S. But I think a more straightforward way is just to split this up into individual terms here, individual area segments. So the first interval is first region here, this little triangle looking region, from 0 to 0.446, top curve minus bottom, so the exponential minus 1. So that will give me the first region here. Okay, the second region is 2 minus 1 from 0.446 to 1.554, and that will give us the middle region, this rectangular region here. and then the triangle shaped region here will be again top minus bottom, the exponential minus 1, but this time from 0.554 to 2. Okay, and that whatever this area is will match what we have here, which is another way that I just talked about it is we can find the entire region of RNS. So exponential minus 1 from 0 to 2. So this will give us all of region RNS, and then we can subtract out R, which we found from part A, and then if we subtract this portion out, we're left with region S as well.